Good morning, students. In the previous video, we have studied chapter number 1 and 2. Now both the chapters are over, so we will start some revision questions from both the chapters together. And if your unit test will be there in the month of July, then these two chapters will come in your unit test. So let us start with the very first one. All the types of questions we are going to discuss here. So first question is, yes. Name the person who developed Boolean algebra. So in the very first video I have discussed that Boolean algebra was this concept, this term was given by George Boole. In which year? In 1854, right? Now second question is, what is the another name of Boolean algebra? So another name is switching algebra. So you can write it, just in short you can write anywhere or wherever you have written the topic. Now next is, in which year was Boolean algebra developed? So here it is, in 1854. Now next is, what is the binary decision? What do you mean by binary valued variable? So you can read out here. This question will come in 1 or 2 marks only, not more than that. And this theoretical type of question will never come, but just only we are going through with these questions. So third question is, what is binary decision? So decision which results into either true or false is called binary decision, right? Now next is, yes, what do you mean by tautology and falsy? So read out here. If the results of any logical statement or expression is always true or 1, then it is called tautology. And if it results into false or all the zeros, that means it is called falsy. For example, if in a given expression, if you solve that expression by using truth table, and in that truth table if you are getting all the entries into that output column as 1, everywhere you are getting 1 in the output column, then it is called what? Tautology. Otherwise, if you will get all the zeros in the output column, so it is called falsy. And if you are getting the mixture of zeros and ones, then it is known as contradiction. Known as contradiction. Now next is, so on the basis of this question can come that question number 4, look at here. On this topic question can come in your exam. That means some kind of Boolean expression will be given to you in the exam, and it has been asked that state whether it's a tautology, falsy or contradiction. So here it is. Now next, what is a logic gate? Name any 3 logic gates. So that also discussed. A gate is simply an electronic circuit which operates on 1 or more signals and produces 1 or more output signals. This one to produce an output signal. Now here the 3 basic gates are NOT gate, OR gate and AND gate. We are having some more gate also, but these are actually known as basic gates. NOT, AND and OR, right? So this question. Now next, 6th. Which gates implement logical addition, multiplication and complement? So you know well, for addition we use which gate? OR. For multiplication we use AND gate, and for complement we need inverter or NOT gate. Done. Now next, what is the other name of NOT gate? You all know NOT gate is also known as inverter gate. Next, what is a truth table? What is the another name of truth table? So truth table is a table which represents all the possible values of logical variables or a statement along with all the possible results of the given combination of values, right? Now next, write the dual of 1 plus 1 is 1. That also we know. Dual question, one question will for sure come in your exam. That means state the principle of duality and state the dual of the following expression. This question will for sure come. So write the dual of this. So you know what principle of duality states that what? 0 will be converted into 1, 1 will get converted into 0, dot will get converted into plus, and plus will get converted into dot. This is principle of duality. So 1 will be converted into 0. For this I am writing plus into dot, then 1 into 0 equal will be same, and this. You can look at here, 1 plus 1 is actually 1 and 0 dot 0 is actually equal to 0, hence verified. Next question, give the dual of the following in Boolean algebra. Now again apply the same, answer will be this, x plus x bar is equal to 1, plus dot will be converted into plus and 0 will be converted into 1 and complement will be same. Complement ही रहता है, it will not get changed. Now for this write the duality, so x will be same, plus into dot, 0 into 1 and it will be same. So you can look at here, because of x plus 0 is x, you know it, and x dot 1 is equal to x. This is also verified. Now next is, here you need to find out which is correct or incorrect. Now a plus a bar is 1, is that correct? Yes, this is complementary law. If I say you a plus 0 is a, yes, correct. Which law is this? Properties of zeros. In this way a dot 1 is a, this is also correct and it is properties of 1. So in this way you can find out, you need not to write which law is this actually, but I am just telling you, here you need to find out only correct or incorrect Boolean equations, right? Now in the same way, like for the next, like D is incorrect because a dot a bar is equal to 0 not 1, so this D option is incorrect. So in this way you will solve it. Now next is a plus ab is equal to a. Yes, how can you say that? Because if you will take a common, inside it will be 1 plus b and 1 plus b is 1, so a dot 1 is equal to a, hence this is correct, E option, right? Next, all the other parts you will try it. Next one, 12th. Significance of principle of duality, that also we have done. Principle of duality is a very important principle used in Boolean algebra. This states that starting with a Boolean relation, another Boolean relation can be derived by, look at here, or to and to or, 0 by 1 and 1 by 0. So this is a very important question, very important question. Principle of duality from the board exam point of view also. Moving on to next, leave this question, 12th. It is asking about the number of combination, like if we are having a n bit number, then how many combinations we can make. So you know it, we can make by n bit number, we can make 2 to the power n combinations, but there is no need this. Leave this question, 13th. Move to next, 14th question. Now you can do it yourself, write the dual of it. Now one I am telling you, just first part, look at here, x plus y bar, so x will be same, plus into dot, complement will be same, so x dot y bar will be the dual of it. In the same way you will find out for B, C and D. This is the complete part and answers also done. Now next, 15th. Find the complement of the following functions applying De Morgan's theorem. Now we will look at the first part and second is the homework for you. Look at here, find the complement, first one, this. Now question is x bar y z bar, first term, plus x bar y bar z. So find the complement. Complements means negation, so write here complement term and write x bar y z bar plus x bar y bar z, right? Now what you will do, you will break the complement from here. When you will break it, now next line will be what? Break it, x bar y z bar complement plus into dot and x bar y bar complement. Done. These two steps write in your notebook, note down करो. उसके बाद what you will do, you will solve this term individually, apply De Morgan's in this and De Morgan's in this. So apply in the first one. Now यहाँ पे apply करो De Morgan's, ये क्या हो जाएगा? It will be x डबल बार डॉट इंटू प्लस, ये हो गया y कॉम्प्लीमेंट प्लस z double complement. This is for first term only. In the same way you will write for the second, make it x double bar plus y double bar plus z bar, right? This, and when you will solve it, this is same as that of this line, okay? And when you will solve it, because you know here x double complement is equal to x, प्लस y कॉम्प्लीमेंट प्लस z डबल कॉम्प्लीमेंट क्या हो जाएगा z. तो फर्स्ट टर्म विल बी दिस x प्लस वाई बार प्लस z. चेक हियर x प्लस वाई बार प्लस z. नाउ सॉल्व द नेक्स्ट टर्म. सेकेंड टर्म विल बी x, ये क्या हो जाएगा कॉम्प्लीमेंट है क्योंकि, तो क्या हो गया x प्लस सॉल्व दिस y प्लस z बार. तो आंसर क्या हो जाएगा डॉट ब्रैकेट्स में यू विल राइट व्हाट x प्लस वाई प्लस z बार. चेक इट हियर x प्लस वाई प्लस z बार. So this is here the answer is. Now second part, solve it yourself. This is homework for you and here is the solution given. You can check your answer later on, but first try it yourself. After that only you look at the solution. Now next, what is the logical product of several variables called? Product of several variables. तो product का मतलब मिनटर्म और प्रोडक्ट टर्म जिसको हम बोलते हैं. एंड व्हाट इज़ द लॉजिकल सम ऑफ सेवरल वेरिएबल कॉल्ड? सो हेयर आंसर इज लॉजिकल प्रोडक्ट ऑफ सेवरल वेरिएबल इज कॉल्ड मिनटर्म. ठीक है, प्रोडक्ट कर रहे हैं ना, प्रोडक्ट एक्चुअली वी डू इन मिनटर्म एंड सम वी एक्चुअली फाइंड आउट इन मैक्स टर्म. सो प्रोडक्ट के लिए आंसर विल बी मिनटर्म and for sum answer will be max term. So here you can look at the answer. Logical sum of several variable is called max term, but that question is actually we cannot say the correct answer as minterm and max term, because here question is what question is about product of several variables. So several variables, if we are using 100 variables and inside that 100 variables we are doing the product of only suppose 98 variables. ठीक है, तो definition तो correct हो गई कि product of several variables 98 variables का अगर हम product कर रहे हैं और 2 को अगर we just leave it, ठीक है, तो वो भी क्या हुआ, वो भी डेफिनेशन को सेटिस्फाई कर रहा है, बट दैट विल नॉट बी अ मिनटर्म, दैट विल बी कंसिडर्ड एज अ प्रोडक्ट टर्म ओनली. सो वी कैन नॉट से इट एज अ मिनटर्म in all the case. So better answer will be what? Product term and sum term. Product term and sum term. But here do not get confused with this, because this type of question will not come in your exam. Okay, but answer can be product term as well and sum term also. This will also be the correct answer. Now next is, what is the procedure? Break the line, change the sign. So procedure, you know what? ब्रेक द लाइन एंड चेंज द लाइन का मतलब क्या होता है? कॉम्प्लीमेंट करना, एंड और को कन्वर्ट करना, और कॉम्प्लीमेंट ईच ऑफ द इंडिविजुअल वेरिएबल्स. बट दिस क्वेश्चन विल ऑल्सो लीव इट, दिस क्वेश्चन नो नीड टू स्टडी, बिकॉज ये क्या एक्चुअली कॉम्प्लीमेंट प्रॉपर्टीज. नेक्स्ट इज, what is a logical product having all the variables? Now this is the correct question. Now here it is asked what is a logical product having all the variables. वहाँ पे क्वेश्चन क्या था? having several variables. तो several variables का मतलब it doesn't mean that all the variables will be there. तो several अगर वो पूछ रहा है तो better answer will be what? product term. ठीक है, product of all the variables product term होगा, और sum of several variables sum term होगा. but we cannot say it as min term and max term. but यहाँ पे क्वेश्चन बिल्कुल करेक्ट वे में पूछा है कि logical product of all the variables. अगर product हो सारे variables का, so that what is that term called? so that term is called min term. and the next question is, what is the logical sum having all the variables? तो sum having all the variables, question is this, sum निकाल रहे सारे variables का, so that term will be known as max term, right? so this is only a revision, but this type of question will not come in your exam, like definition based question नहीं आएंगे. ठीक है, ये question इस type के questions नहीं आते हैं, but this is only to just for the revision only, to remove your confusion and all. now next is, what do you understand by min term and max term? so all you know what, min term is a product of all the literals, and max term is the, here it is wrong, sum of all the literals. max term is the sum of all the literals within the logic system. given here, each literal may be with or without the bar. correct? for for example, if I write f is a function defined on 3 variables a, b, c. So if I say a, b, c, then is that a minterm? Yes. If I ask you a bar, b, c is a minterm? Yes. If I ask you a bar, c, is that a minterm? No. It is only a product term but not a minterm because b is missing here. So minterm क्या कहता है? Product of all the variables. Focus on this all. And actually here b is missing, so we cannot say it as a minterm. And where each and every term may और may not be complemented. या तो उसके ऊपर complement हो सकता है या नहीं हो सकता. जैसे c is a uncomplimented variable but a is a complemented variable. तो हर एक literal का मतलब variables. ठीक है. Now next 21. Yes, this type of question can come again in your exam. 21st, write the minterm and maxterm for a function x, y, z where x is 0, y is 1, z is 0. Now look at here. If I want to find out the minterm, so minterm means x 0, y 1, z 0. Now do you remember that in case of minterm we denote 0 by a complemented variable, like suppose if I am writing a bar and 1 uncomplemented variable. So if I am going to find out minterm for x0, y1, z0, how we will write it? X bar, y simple and z bar. Check here. Done. Now for the maxterm के केस में 0 और 1. 1 is represented by a complemented variable and this is uncomplemented variable in case of maxterm, because minterm is opposite of maxterm. So if I want to generate the maxterm for this combination, so it will be what? See, x0, 0 है तो मतलब simple variable. ठीक है. So x plus 1 है तो complemented variable and 0 है तो simple. Right? So x plus y bar plus z. Moving on to next 22, that is also same. Do it yourself. It is the homework for you. Question is, when x is 1, y is 0, z 0. This is here the question is, and answer is here. Next, write shorthand notation for the following minterms: x, y, z, x bar, y, z bar, x bar, y, z. Now again, shorthand notation for the following minterm. So minterm means we can write it here. 0 means x bar and 1 means x. Now find out for x, y, z. First for this term, find out the minterm designation for x, y, z. X, y, z means 1, 1, 1, which is equivalent to 7 in decimal notation. Now next is, I'm writing it here, x bar, y, z bar. So x bar, y, z bar means 0, 1, 0. It is equivalent to 2. 2 we got, 7 we got. Next is x bar, y, z. Let me write it here, x bar, y, z equivalent to 0, 1, 1. 0, 1, 1 is the binary equivalent of 3 in decimal. ठीक है. So we got 3 terms here, 2, 3, 7. These are the minterm designations. So shorthand notation आपको पता है क्योंकि minterms are used in SOAP expression. So when the question will come in this way, so you will write what? Sigma. Now this is the answer. Look at here. So we are using here sigma. So sigma means minterms जो है that are used in SOAP expression. तो SOAP में use करने के लिए sigma use करेंगे, sigma, and minterm designation we will write in the bracket. This is how we write the shorthand notation. So 237. So f is equal to sigma 237 is the answer. This question is also important. Will come in 1 or 2 marks only. Now next, shorthand notation for maxterm. Now this is again homework for you because here we have to find out for maxterm, and remember one thing, in case of maxterm 0 will be represented by uncomplemented and 1 with complemented, and maxterm में हम क्या यूज़ करते हैं क्योंकि ये क्या है हमारे पास maxterm is same as that of sum term है ना, तो x plus y plus z अगर हमारे पास है तो हम क्या लिखेंगे इसके लिए, just for one I am telling you. So x plus y plus z means 0, 0, 0 which is equivalent to 0. ठीक है. Now same for the next combination, you will find out max term designation. For this you will find, for this you will find, and finally because of max term are used in pose expression, so write pi and bracket में the terms that you will get by solving these four. Right. Now here is the answer. Answer is this. Later on you can check after solving it. Now next, leave the next question. 25, 26, leave it. 27, that is also not important. 27, what is the another name of Karnaugh map and who invented Karnaugh map? So another name is wish diagram, and who gave this term Karnaugh map? Maurice Karnaugh. Okay, that you should know, but not important. Next is this one, again important question, mark it important. Why NAND and NOR gates are called universal gates? Already I gave you the definition. So circuits using NAND and NOR are popular as they are easier to design and therefore cheaper. Functions of other gates can be easily implemented using NAND and NOR gates. For this reason they are called universal gates. Okay, so definition I hope you all have noted down already. Now next is which gates are called universal gates and why? So answer is NAND and NOR gates are called universal gates because NAND and NOR gates are less expensive and easier to design. ये हमने पहले भी डिस्कस किया हुआ था. ठीक है. अब all other functions like not and or can easily be implemented using NAND and NOR gates. That's why we use these gates, NAND and NOR gate, mostly because these are cost effective, also very cheaper, also easier to design, easier to implement. So that's why we use universal gates, NAND and NOR. Now next is state the purpose. That is also not important, but still state the purpose of reducing the switching functions to the minimal form. यानी कि हम switching circuits जो होते हैं उसको minimize करते हैं. Boolean expressions को we always try to minimize or reduce the Boolean expressions. Why? Because I already told you the more the simplified form will be, the lesser the number of gates will be there to design it. तो जितने कम आपके लॉजिकल एक्सप्रेशन से वेरिएबल्स होंगे, उनके ऑपरेशंस होंगे, उतना ही ईजी आपके लिए उनको इम्प्लीमेंट करना होगा, उतने ही कम गेट्स आपको लगेंगे उसको डिज़ाइन करने के लिए सर्किट को. सो हियर इज़ द आंसर. The switching functions are practically implemented in the form of gates. A minimized Boolean expression means less number of gates, which means simplified circuitry. Less number of gates, which means simplified circuitry. So thus the purpose of reducing the switching functions to the minimal form is getting circuitry. Okay, so this is the answer here. Now next, draw the logic circuit diagram using NAND and NOR. Yes, now here it is. What question is this? You have to make the diagram using NAND or NOR. किसी को भी use करके बना सकते हो. And you know what, this is a SOAP expression. This is a SOAP expression, and SOAP expressions are actually designed by NAND gate and pose expressions are designed by NOR gate. So we will design it using AND. Now what we have to do is we have to do the double complement of this term, and you will break the inner complement, and it will be what? A bar, B bar, the complete bar plus into dot and AB bar. Now look at here, this term is converted in NAND form because here it is dot in between that. Here it is dot, here also it is dot. Okay. Now this is also NAND, and the complete term also represents NAND. Now can you make the diagram for it? Okay. कैसे? Now solve first this one. Okay. So A bar and B bar will be passed into NAND gate. So this is a NAND gate and pass here A bar. So A bar will be like this. This is not using NAND, A. ठीक है. And again you will make, this is for B. So ये क्या हुआ? A bar, B bar, A bar, B bar, इन दोनों का NAND निकाला. The output will be passed. ठीक है. Then next one is A dot B bar. A dot B bar means make it here NAND, and you can take it from here. A, B. ठीक है, ये लिया हमने. Now this is for the second one, and then do the complete NAND, because it states here, they look at here, this is and this is not, that means total NAND. So make it like this. This will be the answer. This is given wrong because here they are using OR gate, and question is either make it using NAND or NOR, but यहाँ पे जो साइन दिया हुआ है, ये जो गेट हम यूज़ कर रहे हैं, that gate is representing OR. So this is actually wrong diagram. So make this one, right? Now next question is, how is gray code different from normal binary code? That also we have discussed. Leaving it. Now next, how many variables are reduced by a pair, quad and octet? Leave this question again. Now next, what is inverted AND gate called? Inverted AND मतलब inverted का मतलब not, और this is AND, तो not और AND को combine करके we get what? NAND. Now next, leave this question again. 35, 36, do it yourself, homework for you. 36, just let me show question, complete question to you. This is the fourth part. Okay, now 37th is find the complement of the expression. One part I am doing here and one part homework again. So 37, let me do it. Find the complement. Yes, so complement means negation, यानी कि inversion. तो इसका complement करोगे, so what will happen here? So it will be like x bar plus into dot yz bar plus into dot xz bar, right? Now here, when you will solve it, x bar dot, now in the bracket apply again De Morgan's, because in this term also, that means in this second term you can again apply complement properties, and here also you can apply what? Complement. ठीक है, तो आप इसको जब apply करोगे, so it will be what? y bar plus z bar dot, and third term में भी also apply, it will be x bar dot plus z bar. So here is the answer. Second part homework. Here is the solution given. Check it out. Second part. Written. Hand to hand solve all the questions, because otherwise you will face a lot of problem to just reverse the video again and to check your answers. So hand to hand you solve all the questions. Now yes, for today it's enough. Now in the next video we will discuss type B short answer questions. In that we will discuss about some K-map questions also. So this was for very short questions that can come in your exam in 1 or 2 marks only, not more than that. And simplification, yes, simplification question can come. So we have discussed some important question that means that can come in your exam, and possibility around 80%, 75 to 80%. So some questions are like NAND and NOR gates, and design the circuit diagrams, proof the given expression, that means LHS is equal to RHS, and about universal gates, and simplification of Boolean expression, right? So these are some important questions that we have discussed in type A, very short. In the next video we will discuss about the next one, K-map, and some more questions related on the first chapter. Okay, so that's all about for today. Thank you.